I have a few examples here just to actually go SN1 versus SN2. As usual, the first thing that you're going to do is actually classify your alkyl halide. It simplifies your life, so go ahead and do that. This one right here is a primary alkyl halide. And if it's a primary alkyl halide, it's going to do an SN1 mechanism. I'm sorry, did I say SN1? No, it's going to do an SN2 mechanism. And we do have a strong nucleophile, so this is going to be a good SN2. We're going to substitute the halide, in this case for the azide right here. If you're worried about the solvent, let's use a good solvent. Let's use DMSO for this SN2 reaction. Remember, DMSO is an aprotic solvent, and it helps the SN2 go a little bit faster. Usually the SN2 is slower than the SN1, so you need to, help it along. All right, on to our second alpha carbon right here. This alpha carbon is secondary. Those are the ones that we have to watch out for because the secondaries can do the SN1 and the SN2. So we have to look at what kind of nucleophile we have. And we have cyanide. Is cyanide a strong or a weak nucleophile? It is a strong nucleophile. So a secondary plus a strong nucleophile is going to do the SN2 reaction. And we're going to substitute the halide for the cyanide. If we had actually specified stereochemistry, remember that the SN2 goes with complete inversion of configuration. But we didn't actually specify the stereochemistry of the starting material. Now, this one is the same alkyl halide that I had at the top. The difference is the nucleophile because I have an alcohol right here. This is methanol. Is methanol a strong nucleophile or a weak nucleophile? Very good, that oxygen doesn't have a negative charge, so it's a weak nucleophile. And if you have a secondary and you have a weak nucleophile, we're going to have a carbocation mechanism. We're going to have the SN1 mechanism. And what's going to happen is that we're going to substitute the bromide for the alkoxide. So basically we lose the hydrogen in the third step of the mechanism. In terms of stereochemistry, I didn't actually specify the stereochemistry of my starting material, but if we have an SN1 reaction, we're going to have a mixture of inversion and retention of configuration. So those are all the things you need to consider. Let's go ahead on to our next one. Can you classify this alkyl halide for me? Is it primary, secondary, or tertiary? This is a tertiary alkyl halide, and a tertiary alkyl halide cannot undergo an SN2 reaction. So this has to be a carbocation mechanism. It has to be the SN1 reaction. And we are going to substitute the halide for the OH. Is this a chiral center? No, it's not a chiral center. Notice it has two methyls to it, so I don't have to worry about the mixture of inversion or retention of configuration. One more and then we're done with this examples right here. The last one, I have a primary alkyl halide and I have a weak nucleophile. Can a primary alkyl halide react with a weak nucleophile? No, the weak nucleophile is going to be basically so silly, it's not going to find the partial positive carbon. To find a partial positive carbon, you need a strong nucleophile, a nucleophile that knows what it's doing. This nucleophile is a little bit clueless, so it can find carbocations, but it cannot find partial positive carbon. So this is not going to give you any reaction. It will get your alkyl halide wet, but that's about as far as you're going to go in that particular reaction.